Welcome back to the channel. In today's video, we will be conducting a full technical walkthrough of the Ramnit malware lab at CyberDefenders. Ramnit is a well-known banking Trojan associated with credential theft, browser injection, and long-term persistence techniques. In this lab, our objective is to analyze the sample using professional malware analysis methodology and extract actionable threat intelligence. Ramnit has been active for years and has evolved into a modular malware family capable of data exfiltration and command and control communication. Understanding of these malware operators provide valuable insight into real-world financial threat campaigns. Initial sample inspection: we begin with basic trace of the suspicious file. Initial inspection includes verifying file type, checking entropy levels, and identifying indicators suggesting obfuscation or packing techniques. We also review imported functions and libraries commonly associated with malicious activities. During static analysis, we examine strings, metadata, and p-structure characteristics. Indicators identified during this stage may include suspicious encoded strings, references to network communication routines, anti-analysis techniques, abnormal executable structure. Static analysis allows us to form hypotheses regarding the malware's function before execution. Dynamic analysis setup. Next, we execute the sample inside an isolated analysis environment to observe runtime behavior. We monitor process creation activity, register modifications, file system changes, network connections. Behavioral monitoring provides visibility into how the malware interacts with the operating system. Ramnit is known for establishing persistence mechanisms that allow execution after system reboot. We observe register-based persistence techniques and potential author modifications. Persistence indicators are crucial for detection, engineering, and instant response workflows.
dried out tears of sorrow, lacking all emotion, staring down the barrel, waiting for the final gates to open to a new tomorrow, moving with the motion, following the light that sets me
process injection behavior during execution. The malware attempts to interact with legitimate system processes. Process injection is commonly used to evade detection and maintain stealth. Understanding injection behavior helps analysts identify suspicious memory activity, command and control communication. We analyze network traffic generated by the sample. Ramnit typically communicates with remote infrastructure to receive commands and transmit stolen information. Identifying command and control indicators enables defenders to implement network-based detection strategies. Observations. Disassembly analysis helps reveal internal logic, and functionally we identify routines responsible for data handling, communication logic, potential credential harvesting. Functionally, reverse engineering allows deeper understanding beyond behavioral observation. We compile relevant indicators of compromise identified throughout the analysis: suspicious domains, registry case file artifacts, abnormal process relationships. Documenting IOCs supports threat hunting and defensive detection development. Ramnit remains a relevant example of modular financial malware. This lab demonstrates how combining static analysis, behavioral monitoring, and reverse engineering provides a comprehensive understanding of